Welcome back to maths class. In the last video we looked at frequency tables and we're still looking at data. Now we're going to look at stem plots, which are sometimes called stem and leaf plots. And the reason they're called that is they literally do have one column that's called the stem and one column that's called a leaf. So this first little section is just showing you how do I read a stem and leaf plot. So in this information, I've got the ages of 20 people at a music concert. So the way I read it is explained in the key. 3/2 gives 32 years. Now, the key is really important because these numbers don't always represent, this is not always tens and units. I might have, in a different stem and leaf plot, I might have 3-2 equals 3.2. Or it might equal 320. So I need to be really clear by explaining that in a key. A key is an important part to include in your stem and leaf plot. Don't leave it off. All right, so the way I can read this, notice that all the ages are in order, starting at 18. There were 2 people who were 18. There's 1 person who was 19. Someone was 20, so was somebody else, maybe not friends. Next person, 21. Now, when I say next person, I mean in order. That wasn't necessarily the next person to come through the doors. I've got two 24-year-olds, I've got a 25-year-old, 26, 29, 30, 32. You get the idea. The oldest person is 54, the youngest person is 18. And let's double check that there are 20 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes, there were 20 ages represented here. So let's make our own stem and leaf plot. These scores are the number of marks obtained by 26 students in a quiz. Now, I don't know what the quiz was out of, okay? For all I know, someone here got full marks. I don't know. The highest mark I can see at a glance is 82. Maybe it's all out of 200. Who knows? I don't know. What I do know is these are the marks that 26 students got, and I can put this into a stem and leaf plot. So let's do that. First, I need a stem and a leaf. So I put a line down the middle and I label one side stem and the other side leaf. Okay, and then I'm going to have to do this in 2 stages. Going back to this, I want you to notice again, these numbers are all in order. Getting them in order the first time is too tricky. So what we do is we do it twice. We do it one time when I get, what's the youngest? It starts at the 4s. Yep, there's nothing smaller than 4. I said youngest. This is not age anymore, is it? Nothing smaller than a 4. I've got 4s and 5s. I've got 6s. I've got a 7 and I've got an 8. So I'm going to sort those out and then I'll put them in order. So this step is kind of tedious, a bit like doing your frequency table. I know this is kind of tedious. It's also very easy to make a mistake by leaving off one number. And if you're doing a long question, which is asking you then to find things like mean and median afterwards, if you make a mistake at this stage, everything's going to be wrong that follows. So you need to make sure, boring though it is, that you don't make any mistakes. So I'm going to put the numbers in: 53, 62, 71. Oh, and there's 30s. That's okay. I can squeeze it in. 37. Okay. It's a really good idea when you're done to check how many numbers you were told you started with, and then to check you've got 26 numbers. 1, 2, 26. So I still might have made a mistake, but at least my mistake wasn't leaving off a number. Now what I need to do, so my first step is this. My second step is I need to put them in order. All right, so let's scoot that up a bit and I'll do a second version of this. So now I'm just going to copy these down, but putting the numbers in order. 37. Now I've got to start with the smallest number, and now's a good time to point out one of the things I did here. Notice how these are all lined up in neat columns. It's really important that if there's more numbers in one row, then that is the longest row. by a proportionate amount. So these numbers are all lined up more or less in columns. I don't rule it, I don't draw lines, but I still do it as neatly as I can. So let's look at my 40s. I've got 5 numbers. The smallest is 2. Then I've got 3, 5, okay, and I double checked that I've got 26. All right. Now I've only answered half the question, but first let's just look at what I've done. These are all lined up. If I put my ruler here, I can see that that's pretty much in straight vertical lines for each separate number. So let's read the second half of the question. Summarize the data in a stem and leaf plot and comment on what the shape of the distribution tells us. The shape of the distribution is about where are all the numbers. Most of the numbers are here at number 5, and then it's fairly evenly spread before and after it. Okay, slightly more numbers up here at the higher end, but barely. I would say that this distribution is approximately symmetrical. It's not exactly symmetrical, but if I make this my middle, I get almost symmetry on either side and almost symmetry on either side. And this is an 82, it's not an 89, so it's pretty close to my 70s. It just missed out on being in my 70s. So I would describe it as almost symmetrical. That'll do. In the fourth example, we're asked to record, in the fourth example, we're going to record the ages of these 20 people who are attending an evening class in a stem and leaf plot. But the problem that I have is I'm only going to have 3 rows. I've got 19 and I think I've got an 18 somewhere, yep, there. So I've got some numbers starting with 1. I've got a lot of numbers starting with a 2 and some numbers starting with a 3. But in my first row, I'm only going to have 1, 2, 3, 4, there's a 17. Right, so it's not going to really give me a good idea of how the numbers are spread out, where all the data is, if I just do it in 3 rows. So the solution for this is I break them up into 2 groups, and my 5 is going to be my cutoff. So what I'm going to do, I'm going to start with a 1, and I'm going to put a little asterisk next to it, and I'll explain what that means in a minute. Then I'm going to have a 2, and then I'm going to have another 2 underneath with an asterisk, and then I'm going to have a 3. I think that's going to cover me. I don't think I've got anything bigger than 35. So well, actually, let's put it in our key. Basically, I'm going to divide the numbers, and most specifically the 20s, in between 20 to 24 and 25 to 30. So 18 is going to go here. 27 is going to go in the second half. 31 goes here. 19 goes here. 25, 5 and up, goes in the asterisk half. So 25 is going to go here. 22 will go in the first half. 20. So now I'm just going to rewrite it in order. So I take the numbers that I've got and I write them in order. So I've got 1 asterisk, now it's clearer to me where the numbers are. It's really obvious that the late 20s is the most common year, with quite a lot of in the groups around it, but of course then there's nothing higher than 33. So that tells me something about the distribution. Whereas if I had this in just 3 rows, this 20s would have been one really long row, and it wouldn't have told me, for example, that there are far more people in the late 20s than in the early 20s. So that's the way we do that when we have a very small number of rows in our stem and leaf plot.